Okay, starting the beautiful rhombus. You might see this word, rhombi. It's an awesome math word. It just means if you have more than one rhombus. So instead of saying rhombuses, we say rhombi. Okay? So the real only difference that makes something a rhombus versus a parallelogram is the fact that the parallelogram, the opposite sides have to be congruent to each other, whereas the rhombus, all four sides are the exact same length. So it's as if you took a square and then you just like pulled it a little bit on the side, so it looks like that, okay? So all four of these are the same. That's what makes it a rhombus. It's just a special type of parallelogram, so it keeps all those properties of a parallelogram as before. So it has the four properties plus the fact that the opposite sides are parallel, okay? We also get to add three properties because of the fact that we have this new shape. So number one is all four sides are congruent. That's the biggest one, okay? The other thing is diagonals are perpendicular. So if we remember perpendicular, that means intersects at a right angle, okay? So that's what I'm saying here. This diagonal and this diagonal create a right angle. So this is a little right triangle, this is a little right triangle, this is a little right triangle, and this is a little right triangle. That's going to help us a lot when we're finding angles. Diagonals bisect opposite angles. Bisect, cut into two equal parts, cut in half. So when we see that, what we're looking at is it slices it right in the middle. So if the whole thing is 100, each of these is 50. Now the thing is, these ones are going to be the same as these. These ones are going to be the same as these. So it ends up being pretty nice because you end up having you're having identical right triangles all in here. But just remembering that these are the same, okay? Looking at my first practice problem, it says EF is 23, EF 23, DF is 40, okay? And we know in the outside, these are all the same if it's a rhombus. So this is 23, this is 23, this is 23, okay? The other thing that we know is the fact that this gets bisected, so each of these is going to be 20, okay? What else do I know? That's really it for right now. I do have these right angles in the middle, and that's awesome. So we want to also find potentially this inside one, just because I know they're going to ask for it because I've done the problems already. I'm going to look at this really pretty triangle right there. Why not? With its right angle here. And I'm going to draw it out. This is 20, this is 23. Let's just throw x there for right now, okay? How do you find x? Pythagorean theorem, same as always, okay? So I'm going to have, I don't know if you can see that, yeah you can. 23 squared equals x squared plus 20 squared. 23 squared is going to be 529 equals x squared plus 400. We know that one in our heads. Minus 400, minus 400. X squared equals, this is going to be 129. What do I do at that point? Square root, square root. We only care about the positive right now. And that's 11.36. This is 11.36. This is 11.36. Okay. GF. GF is 23, HF is 20, GH is 11.36, GE the whole length. So let's do 11.36 times 2, and that gives us 22.72. So that's our answer here, 22.72. Okay. Number 4, it says find the missing measures. Fill in what you do know. So this is really the only angle that I have. It's a parallelogram. All these sides are the same. All the insides are 90, which is nice because I already know that one's 90. Now, if you remember back, these are the same. These are the same. Okay? So this is 38. This is 38. This is 38. We gotta find these ones. Well, I know they're all the same, so let's just focus on one triangle right now, okay? I might do that top one, why not? Looks pretty. There, there, there. Right angle, 38. X. Perfect. Let's find it. 180 minus 90 minus 38 equals 52. So this is 52, this is 52, this is 52, this is 52. Okay, let's see if we need anything else. I don't think so, so let's just fill in. Number 1 is 52 degrees, 2 is 52 degrees, 3 is 38 degrees, 4 is 38 degrees, 5 is 38 degrees, 6 is 52 degrees, 7 is 52 degrees, and 8 is 90 degrees. That's that on that one. Okay, looking at this next thing, we have a square. I'm not gonna lie, I have a feeling you already know a lot of these properties. However, we're gonna go over them just in case you don't. A square is yet again another special type of parallelogram. Reason why is opposite sides are parallel. This one's special though. It has a combination of pretty much everything. It has the combination of all the properties of parallelograms, rectangles, and rhombuses, which is rhombi, okay? So, we'll look at what this actually does to the problem, okay? We have all the sides on the outside are the same. We also know that all of the insides are the same, which works with the rectangle. We also have that the insides are perpendicular. They bisect the outside angles, which are all right angles because of the rectangle. But look, the whole thing is 90. So if it's bisecting it, because I know that's a property for a rhombus, each of them is going to be 45. So these ones end up being pretty simple if they're asking for angles, because the answer is either going to be 90 or 45. Side lengths, they're all the same in the middle. They're all the same outside. They're not the same number, but they're all the same, okay? Insides, outsides the same. That's pretty much it for a square. Let's see how this works. Okay, why does my number 6 look a little bit different than yours? Because of the fact that it gave you one picture. However, it asked for sides and angles and for you to do computation on both. I always split it up to make it one's for sides, one for angles, because of the fact that you kind of need more space for us to not make mistakes. So take that extra minute and draw out that extra side, and let's get started on this one. It says it is a square and AD is 11. So if this is 11, this is 11, this is 11, this is 11, okay? I have right angles in the middle, right angles. The big ones are right angles, okay? I have two chances here to figure out the insides. I can use this little triangle and call the hypotenuse 11 and call both of those x's. It takes longer. Instead, when they're giving you the outsides, use the big right triangle, okay? When they give you the insides, use the little right triangles, okay? So this is what I got. Right angle, 11, 11. This whole thing here is going to be x, okay? Don't forget, it's not just that part, it's the whole thing. So let's set this up. X squared equals 11 squared plus 11 squared. I'm going to change this to a better marker. X squared equals 121 plus 121. Remember, we can actually do that in our calculator in one step. I'm just breaking it down so that you can see it. Square root, I get x equals 15.56. Remember, that whole thing is 15.56. But I might now just want half of it, okay? So let's divide that thing in two. 15.56 divided by 2 equals 7.78. So each of these is 7.78, 7.78, 7.78, 7.78. And if they want the whole things, it's the 15.56, okay? So let's look. BC is 11. AC is the whole thing, which is 15.56. BD is the whole thing again, 15.56, and EC is 7.78, okay? Moving down on this next part, they want angles. beautiful. Love it. I'm just going to fill them in real quick. These are all 90. These are all 90. The whole things are 90. The whole things are 90. The whole things are 90. And each of these is 45, 45, 45, 45, 45. Lots of 45s. Okay. Let's look. Angle DAB. DAB is that whole length, or whole angle, which is 90. AEB is 90 also, but it's the 90 inside. CBD is 45, it's half of it. BAC, also 45. Okay. Number 7. It says this is a square and TR is 17. TR is this part, so this is 17. This is 17. This is 17. This is 17. The whole thing is 17 times 2, which is 34. And it's the same on the other one. Okay? Yet again, I want to find these outsides. Now, when you get the numbers in the inside, I recommend just using the little triangles instead of the big triangle, okay? Yet again, you can solve it however you want. You could have done that one, or you could have used the big one, but sometimes when you guys divide by 2 and square root, it ends up looking real weird. This is what we got. I'm going to say this is x out here. Let's go through Pythagorean theorem. X squared equals 17 squared plus 17 squared. That's x squared equals 289 plus 289. X squared equals 578. Square root. X equals 24.04. Give me the decimal, don't leave it as 24. Okay, this is 24.04. Same all the way around, same all the way around, same all the way around. PR, full length is 34, we decided. QS, also 34. QT, PQ. Nice. Got on to the angles. Love, love, love the angles of a square. So simple, don't need numbers. You can fill everything out, which is kind of cool that you have an entire problem where you don't actually need an entire or any numbers to figure it out. I don't know if you guys find that cool, but I find that really cool. Here we go. PRS is 45. STR is 90. PSR 90. QPR 45. Okay, moving on. I like this next part. Put a little algebra in there. We have, it's a rhombus, so first thing I'm thinking, okay, same. Find angle FED. What do I know about these? Well, if you remember, these ones are the same in a rhombus. Those are the same in a rhombus. So I'm going to set them equal to each other because that's what I know about them. And let's do some math gymnastics here. Okay, add 20 to the other side. Divide by 3, we get x equals 7. Okay, so looking at that, we get x equals 7. Awesome, love it. Still not my answer. We want the measure of angle FED. So let's find that where that is, FED. Okay, that's that whole angle there, okay? So what I'm going to do is I'm going to figure out, well, technically speaking, what do I know about the inside here? Right angle. I'm going to focus on, let's go with, I like those numbers actually better, so let's focus on this triangle right here, okay? Right angle. Let's draw that out. Okay. So, we got our 90 degrees. We're going to want to find this. We don't know what it is yet, but let's find this first, okay? So, how do I find this? Well, this is at 5x plus 1, which is 5 times 7 plus 1, which is 35 plus 1, which is equal to 36. So this is 36 degrees. This is 36 degrees. How do I find up here? I do 180 minus 36 minus 90. Remember, you could just do 90 minus 36. It gives you the exact same answer, but we're going with it. This gives me 54 as an answer. So this is 54 degrees, this is 54 degrees, this is 54 degrees, this is 54 degrees. We want the whole thing, so what am I going to do? I'm going to do 54 times 2, which is 108, which is my answer there. I got one more problem for you. This, so cool. What do we know about it? Literally nothing until you think about the fact that Malibu is having a coronary downstairs. Okay, so what do I know? The whole thing is a 90-degree angle. Each of them is 45, 45. Okay, so what do I know? This angle is equal to 45. So that's what I'm going to do. 7x plus 3 equals 45. Subtract 3, subtract 3. I get 7x equals 42. Divide by 7, divide by 7. And I get x equals 6. That's it.